In the last section, we used a Taylor polynomial to approximate more complicated functions. Thank you. For example, the 4th degree Taylor polynomial for e to the x is that polynomial right there. Now, remember that that's an approximation. So we would have to use the little squiggly marks to say e to the x is approximately equal to that. And the higher the degree of the polynomial, the better the approximation is. Well, a power series is an infinite degree Taylor polynomial. And many functions can be represented exactly by a power series. So e to the x is exactly that Taylor polynomial with an infinite number of terms. So if you're talking about an infinite Taylor polynomial, then it's called a power series. All right. A power series is defined as this, and because it's an infinite series, we can use the summation form from n equals 1 to infinity. And a sub n represents the Taylor coefficient, so the nth derivative over n factorial. And then you have x to the n, because in a Taylor series, you've got your x term, your x squared, your x cubed, x to the 4th, etc. This power series happens to be centered at x equals 0. If the power series is centered at c, then you have your a sub n times x minus c to the n power as your formula. So the first thing I want to do is determine where the following power series are centered. So where do you think a is centered? No. 0. Right. C equals 0. All right, where do you think b is centered? 2. And where do you think c is centered? Negative 1. We haven't had much experience with c being negative numbers, but that point of tangency for the polynomial is, it can be a negative number. That's no big deal. A power series that's centered at x equals c will always do one of the following. It will converge at x equals c only. So the only place that it will converge is when x happens to equal c, wherever you're centered. So like back on part A, the series was centered at x equals 0. So when x equals 0, if you plug that into the series, that series will converge. The series will converge absolutely for all x. So no matter what x is, the series will always converge. Or it will converge a finite distance either way from the center. And that's what happens most of the time, is that you've got this, what's called an interval of convergence. So a finite distance from the centering point, it will converge. And in that case, there exists a real number r such that the series converges absolutely for the absolute value of x minus c less than r. Okay, I want to talk about what this means. However, before we do that, if you have, say, the absolute value of x is less than 3, do you all agree that if the absolute value of x is less than 3, that x is between negative 3 and positive 3? So if the absolute value of x minus c is less than r, then that's the same thing as saying that negative r is less than x minus c is less than r. And this number r is called the radius of convergence. So that's how far from the center that series will converge. So if we solve this inequality for x, if I add c to both sides, then I get c minus r is less than x is less than c plus r. And what that means is your center is at some value of x, or your center is at some value. And if you add r, so here's your center, and if you add r, you would be at the point c plus r, and if you subtract r, you would be at the c minus r. So this whole interval between c minus r and c plus r is x, and all those values of x are where the series converges. Okay, and we're going to do this in a real example, so if that's still kind of fuzzy, don't freak out, because it's not that big a deal. So that number r is called the radius of convergence, and the way that you want to think about that is how far from the centering point, from that c value, can you go to the left or to the right and still converge? All right, so if the series converges only at c, then what would the radius of convergence be? How far can you move away from c and still converge? 0, right. Kind of a trick question, I guess. if the series converges for all of x, then what would your radius of convergence be? Infinity. And no matter what, the series will always converge at C. So it may just converge at C, like number 1. It may converge everywhere, or it may just converge a finite distance from C. All right, and then the set of all values of x for which that power series converges, so what we talked about right here, this little interval, is called the interval of convergence. Or I want to find the radius of convergence of this power series. And in order to do that, we use the ratio test. So the problem is to find the radius of convergence for this power series. Use the ratio, not ration test, to determine the values of x for which the series converges. All right, so the ratio test. Who remembers what the ratio test is? Okay, it's the limit as n approaches infinity of the absolute value of a sub n plus 1 over a sub n. All right, well, a sub n plus 1 just means everywhere I see an n, I'm going to put in n plus 1, and then divided by a sub n. Right, everything except x minus 2 cancels. Your 3's will cancel, and then x minus 2 to the n plus 1 over x minus 2. Limit as n approaches infinity of the absolute value of x minus 2. Now, we're taking the limit as n approaches infinity. So the limit as n approaches infinity of x minus 2 is what? Just x minus 2. And in this case, it's the absolute value of x minus 2. Okay, now the reason that that equals x minus 2 is think about the limit as x approaches infinity of 5. So graphically what that means is what is the y value of the graph of y equal 5 approaching as x approaches infinity? It's 5. So whenever the variable that you're trying to take the limit as, say, x approaches infinity, if that variable is not part of the actual limit problem, then your answer is just what that thing is right there. So that's why this is just x minus 2. Now, think back to the day that we did the ratio test. In order for a series to converge, this limit that you get from the ratio test needs to be what? Less than 1, actually. All right, so whatever you get for this limit, which in this case we got the absolute value of x minus 2, well, in order to converge, I need for that limit to be, or that limit to be less than 1. And this will allow us to figure out the x values that will allow this series to converge. So when we have an absolute value less than 1, then I can take it, I can change it to negative 1 is less than x minus 2 is less than positive 1. And then when I solve for x, I get that 1 is less than x is less than 3. So that's my basic interval of convergence here. I used the ratio test, I found my limit, and then I had to find the x values that would make that limit be less than 1. And those x values are between 1 and 3. All right, so to answer the question of find the radius of convergence, I'm going to kind of go through these questions. What's the center of the interval that we got in part A? 2. Look back up at the original power series. What's the center? Where is this power series centered? At 2. Those two numbers will always be the same. Your power series will be centered at the same number as the interval that you get from the ratio test is centered. All right, so if this interval is centered at 2, then how far left and right can we go of 2 and still be in that interval? 1. I can go 1 to the right and I can go 1 to the left. So therefore, the radius of convergence is 1. Now, parts B, C, D, and E, I'm not going to ask you those separately. From here on out, I'm going to expect you to look at this interval, find the center of it, and then figure out how far can I go from that center to the endpoints, or what's the distance from the center to those endpoints. So anytime you see radius of convergence, you start with the ratio test. You're always going to set this limit that you get from the ratio test less than 1, because the ratio test says that in order to converge, this limit has to be less than 1. So you're trying to find the x values that make this series converge. All right, right now, 1 and 3 are actually not included in that interval, but we're going to go ahead and say that the radius is 1 because it's getting infinitely closer to 3. And it may or may not include the endpoints, and that's what we're going to talk about in just a second. Okay, so same thing. Find the radius of convergence for this power series. So we're going to start with the ratio test. So the limit as n approaches infinity. A sub n plus 1 will be n plus 1 factorial times x to the n plus 1 over a sub n. That's absolute value. Okay, what happens to my factorials? How can I reduce that? Yeah, just an n plus 1 times x. Now, no matter what x can be any number at this point because it's a variable, but no matter what x is, as n approaches infinity, what does that limit equal? Infinity. So it doesn't matter what x is, that limit is always going to equal infinity. So yes, because of the absolute value. If x is positive or negative, the absolute value of it will be positive, and so the limit is infinity. Is there any value of x that will make that limit be less than 1 so that this series will converge? No. However, a series always converges at its centering point, and therefore the radius of convergence is 0. Okay, so no matter what, a series will always converge at its centering point. In this case, it's centered at x equal 0. So n factorial times 0 is just 0. So when x equals 0, I've got the sum of 0 from n equals 1 to infinity, which 0 plus 0 plus 0 plus 0 is 0, and it converges. Yes, so if your limit equals infinity, the radius will always be 0. Okay, find the radius of convergence for this. We've got to be really careful when you are finding a sub n plus 1 on this one. And remember, we're taking the absolute value here, so negative 1 to any power, and then the absolute value of that will always be a positive 1, so I don't really need to think about the negative 1 to a power. But when I plug in an n plus 1 for n, what do I get? 2n plus 3, bingo. X to the 2n plus 3, because I'm taking 2 times what was n and then plus 1, and I'm replacing n with n plus 1. So you have to multiply 2 times that whole quantity n plus 1. And you get 2n plus 2 plus that 1 is 2n plus 3. All right, so therefore on the bottom we have 2n plus 3 factorial. And then instead of dividing by a sub n, I'm going to multiply by the reciprocal of a sub n. Okay, my x to a power. When I reduce that, what do I get? X squared, right, on top. Because if you subtract 2n plus 3 minus the whole quantity, 2n plus 1, you're going to be left with 2. All right, and then the factorials, 2n plus 3 is bigger, so I'm going to have 2n plus 3 times 2n plus 2, and then 2n plus 1's factorial cancel. All right, so as n approaches infinity, what is that limit? 0. So no matter what x is, that limit is always 0. So for what values of x does this series converge? Right, it's going to converge for all of x, so therefore the radius of convergence would be, if I converge for all values of x, then how far can I go from the center in either direction? Infinity, right? Yeah, so when your limit from the ratio test is infinity, your radius is 0. When the limit is 0, the radius is infinity. Okay, there are two types of questions that they ask. One is, what is the radius of convergence? The other is, what is the interval of convergence?